Basic differentiation rules. All right, notice the connection. If f of x is 3x squared, then f prime of x is 6x. If f of x is 3x to the third minus 4x squared plus x, then f prime of x is 9x squared minus 8x plus 1. Now pause the video and think about that for a second. Do you see a connection? Hopefully you do. And now we're going to try the next one. If f of x is x to the fourth minus 4x, and notice that would be to the first power, I want you to write in the blank what you think that is. And number 4, f of x is 2x plus 5, and I want you to write in the blank what you think that answer is. Pause the video. Hopefully you got that these two answers were what you selected. Let's look at number 4. You should recognize that number 4 is a line, and so the slope of that line is 2. And remember that a derivative function is the slope of the tangent line for every x on the function f. Well, notice here what happened was our derivative function appears to be 4x cubed minus 4. And if you look at each of these, it looks like what happened was the exponent on your x came down and multiplied by the constant, and we reduced the power of our x by 1. And that is what's going on. Now, what happened over here with 4x? This is 4x to the first power. The 1 comes down, is multiplied by the 4, leaves x to the 0, and you know that x to the 0 is 1. So now we have some basic derivative rules. You know, the last section where we did the definition of derivative, there was a lot of algebra that had to be done, and we really don't want to have to do that for every time we're looking for a derivative function. So let's develop some rules that are very nice. One is the derivative of a constant. Think about it. If you have a constant function, let's say y equals 4. That is a horizontal line at y equals 4. What is the slope at every point on that line? Well, it is 0. So if you look at each one of these functions, these are all linear functions. Therefore, their slopes will all be 0. Notice that in number 4, k is a constant. So this brings us to our general power rule. The derivative with respect to x of an x to the n is, the n comes down as our coefficient of x, times x to the n minus 1, so reduce that power by 1. So we're going to look at some functions here, and let us see if we can find the derivative. So if f of x is 3 times x to the fourth, then its derivative, notice the 3 is a constant multiple in front, the 4 would come down and multiply by the 3 that is there. Now for the next problem, I'm going to introduce an acronym I like, FROTH. FROTH, we're going to see this a lot. Fractions are our friends. FROTH. Be sure you know that. So when we look at number 2 here, we can see that we want to write this with fractional exponents. And if we write this with a fractional exponent, it now becomes quite simple. The 1/3 comes down as a coefficient. So g prime of x is, let's take the derivative with respect to x, x to the 1/3. This is what tells you this is what I'm going to do. The 1/3 comes down, x to the 1/3 minus 1. This is a middle school math concept. 1/3 minus 1 is negative 2/3. And we don't want to leave it like this. So 1/3 times x to the negative 2/3 is really 1/3 times 1 over x to the 2/3, which looks like this. That's an acceptable answer. Might not be one that you see on multiple choice questions, so you might want to clean it up and look at it like this. 3 times x to the 2/3, so the cubed root of x squared. You could see this type of answer a lot of ways. So if we look at y equals 1 over x squared, we first of all want to start with that being x to the negative 2, because we need a power on the x. And now negative 2 comes down for my derivative, x to the subtract 1 from that. We're still basically doing middle school math or even elementary. I don't know where you learn negative 2 minus 1. That gives us -2 times x to the -3rd. We want to write this without negative exponents. Now notice your exponent is only on the x. So when I write this as 1 over x to the 3rd, the -2 stays on top. Okay, we're going to now do an example similar to what we did in the last section, but much more quickly. So find the slope of the graph f of x equals 3x squared when x is 2. So finding the slope the fast way, not definition of derivative way, tells us that our slope function is 6x. We now need to find the slope when x is 2. So f prime, notice that notation of 2 is 6 times 2, which is 12, which is the slope of the tangent line when x is 2. Now we're ready for an equation of a tangent line. We have our slope, we have our x-coordinate, but we need our y-coordinate. So we're going to substitute 2 into f of x to get our y-coordinate. When x is 2, y is 12. We have our slope at 2 to be 12. And we can write our equation of our tangent line through the point using point-slope form, and it looks like this. Now, it is okay to leave it in this form. It says find the equation of the line. It doesn't say, really, it should say find an equation. It could be in any form. I could add the 12 over, making this y equals 12 times x minus 2 plus 12, or y equals 12 plus 12 times x minus 2, or I could distribute the 12 and add the 12 to that when I do that. You would only do this if you're actually asked to put it in slope-intercept form. If you're not asked to put it in slope-intercept form, then don't do that, okay? Because if you make mistakes and you had it right here and you make a mistake getting to here, you get penalized, so be careful. Okay, well, now we're going to go through a process of working with derivatives. So first of all, we have our function y equals 4 over 3x squared. We need to write this so that we have a exponent on our x. So we want to rewrite this as 4/3 x to the -2. Now the derivative is our step where we make sure we're using all of our proper notation. That's going to be y prime, and 4/3 stay there, and the x to the -2 becomes -2x to the -3rds. And now we're going to clean it up. You can see the -2 times the 4 is going to leave me -8/3, and then the x to the -3rd is going to put the x to the 3rd in the denominator, and that's what your answer is going to look like. All right, let's look at problem 2. It's a little different from problem 1. Notice that all of 3x squared is in the denominator, so we might want to rewrite it. There's a lot of ways to think about it. I think the easiest way to think about this problem is to rewrite this as 4 over 9x squared. And then we could rewrite that as 4/9 times x to the -2. Now, I'm ready to take the derivative. 4/9, the derivative of x to the -2 is -2x to the -3rd, and here we clean it up. However, you will notice I thought about this a whole nother way. We could also write this as 4 times the quantity 3x to the -2. I then have to write this as 4 times 3 to the -2 times x to the -2. I still get to the same answer. Pause your video and write all that down now. Number 5, let's look at how we want to rewrite this. Notice that 5 over 3x to the -2 is really 5/3 x squared. So when you write it like that, it is very easy to take the derivative and then simplify. And again, if we look at number 4, 5 over the quantity 3x to the -2, that is really going to make it 5 times 3x squared. 3x, the quantity squared, is actually 9x squared. So now I'm looking at 5 times 9 times x squared, which gives me 45x squared. And that is easy to find my derivative and simplify. Again, freeze your video and write all these notes down now. Okay, the sum and difference rule is quite simple. We take the derivative with respect to x of f plus g, which gives us f prime of x plus g prime of x. And of course, if it's a difference, it is f prime of x minus g prime of x. Very simple, very obvious. So here is our equation. If we want to take the derivative, I'm taking the derivative of each term. So that will give me 2x squared minus 2. Let's look at number 2. Example 2. Just have to think carefully. That is really a negative 1/2 times x to the 4th, but negative 1/2 times x to the 4th, the derivative of x to the 4th is 4x cubed. The 2 comes down to the 5, makes it negative 10x to the 1st plus 3, and you can simplify that a little bit. Derivative of sine and cosine. In class, we're going to look at this. It's rather neat, but the derivative of the sine function is the cosine function. The derivative of the cosine function is the negative of sine. So if we look at y equals 6 sine of x, the derivative will be 6 times the derivative of sine, which is cosine. If I have sine of x over 3, we want to rewrite that as 1/3 of sine x. The derivative would be 1/3. Derivative of sine is cosine x. And now let's make it a little bit more complicated. Y equals 3x plus 3 cosine x. Therefore, y prime would be 3. And then 3 cosine x would make me 3 times the derivative of cosine is negative sine, and then I would clean it up. So, as we've discussed before, the derivative can be thought of as a rate of change of one variable with respect to, WRT, another. Examples include population growth rates, production rates, water flow rates, velocity, acceleration. There's many, many applications. A rate of change is most commonly used to describe the motion of an object moving in a straight line or in a horizontal or vertical line. A position function gives position s of t, or very often you will see x of t, of an object of a function of time t. And the interesting thing is we have average velocity, which is the change in s over the change in t. Doesn't that look like slope? In this example here, you can see we have a position function. S of t is negative 16t squared plus 50, where s is in meters and t is in seconds. We're going to find the average velocity. Vocabulary-wise, average velocity means slope of the secant. So the average over the interval from A to B. Well, that's f of B minus f of A over B minus A. You know that from earlier in this course. So I'm looking at the time interval from 0 to 2. So s of 2 minus s of 0 over 2 minus 0 gives us negative 32 meters per second. Now let's tighten up that interval and say let's look from 1 to 2. So that would be s of 2 minus s of 1 over 2 minus 1. So in that smaller interval, we're falling faster than we were before. And now look at 1 to 1.5. Let's tighten up that interval a little more. S of 1.5, S of 1, and I get negative 40 meters per second. So I have an average rate of change, AROC, average rate of change. Now, the average rate of change is negative. That means your object is falling, or if we're moving linearly to the right and left, it means we're moving to the left. Now, instantaneous velocity, instantaneous rate of change, IROC, instantaneous rate of change. This is the slope of the tangent line at the point. So secant line is average velocity, tangent line is instantaneous. So if I find the instantaneous rate of change, that means find the derivative of this, which is negative 32t, and evaluating it at 1.5 gives us this. This gives us how fast the particle is falling at exactly 1.5 seconds, which is different from over the span of 1/2 of a second. The velocity function is the derivative of the position function. That is a key idea. Velocity can be positive, negative, or 0. When the velocity is 0, the object is usually, not always, changing the direction in which it is moving. And a big concept, speed is the absolute value of velocity. Since speed is the absolute value of velocity, it's always positive, but the direction an object is traveling is not always positive. Let's remember that. Velocity can be negative. It tells us the direction the object is moving. The acceleration of an object is the derivative of its velocity. So If I take the derivative of velocity, I get acceleration. And by the way, notice that acceleration would be the second derivative of position. That's going to come into play in the near future. If an acceleration of an object is negative, the object's velocity is decreasing. If the acceleration of an object is positive, the object's velocity is increasing. And your free fall function in feet per second is s of t equals negative 16t squared plus v naught t plus s naught, where v naught is your initial velocity and s naught is your initial position. Important things to know: if an object is dropped, its initial velocity is 0. If an object is thrown down, its initial velocity is negative. If an object is thrown up, its initial velocity is positive. These are all important facts you're going to use in the future. So on this page, you will see facts about distance, velocity, and acceleration. You really need to look at this. You will not know how to do this bullet point yet, and you will not know how to do this bullet point yet, but everything else on this page you are responsible for knowing. Your TPs for this section are 5 and 9. You get to use the fast way. 13 is the limiting process, what we did in section 2.1, just to refresh your memory. And number 25 and 29, see you in class.